Hello and welcome to the YouTube channel of the Bhopal School of Social Sciences. Today we are beginning a new subject which is Mathematical Physics and Special Theory of Relativity. In this subject we will study about differential equations, vector algebra, vector calculus and Fourier analysis, out of which we are starting our first lecture with differential equation. Now, before diving deep into differential equation, we will start understanding this unit or this topic in the most simplest way, that is by understanding its heading or the title of the topic, which is differential equation. This title comprises of two words, which is differential and equation. So, we will start with equation. What is an equation? An equation is a form of expression through which relations between variables and constants are presented. For example, y is equals to 3x plus 8, which is the simplest equation of a line. Another example, suppose x square plus y square equals to 64, which is an equation of a circle. Here we can see that y and x are two variables, out of which one is definitely a dependent variable and another is an independent variable. Now, suppose we are taking in y equals to 3x plus 8, x is equals to 2, which will give us y is equals to 14. So, here we can see that for one value of x, the equation is giving us one value of y, which is a static result. But in physics, nothing is static. Everything is in a motion, whether it's a temperature or a particle or a vehicle or a charge. Everything is in a motion. So, to understand physics in a better way, we need something else, something more than just an equation of constants or variable. So, we will now jump next to the another topic, that is differentiation or derivative, which measures how one quantity changes with another. For example, we are very well aware about the term velocity or acceleration, which is change in position with respect to time, whereas acceleration is change in velocity with respect to time. So, here one or more other quantity is changing with respect to another. Suppose let us again consider the first example which we have taken, y is equals to 3x plus 8. Now, if we differentiate this equation, we will get dy by dx is equals to 3. So, here we can see that the y is changing with respect to x. This is the simplest form of differential equation we can get. Now, let us move on to the next. So, while combining the equation and derivative, we get differential equation, which is an equation containing one or more derivatives of a dependent variable with respect to one or more dependent variables. For example, d square y by dx square plus 2y is equals to 3. It is an example of a differential equation. Another example, this next example is a little bit more complicated comparable to the first one, but here if we focus in both equations, y is depending on x. So, the differential equation is classified on the basis of how many variables a dependent variable is depending upon. If a dependent variable is depending on one variable, then those equations are known as ordinary differential equations. For example, the equations which we have written in the screen are all examples of ordinary differential equation. But in physics, it is not compulsory that any quantity is depending only on one variable. There might be more than one factors over which quantity may be depending upon. So, those equations in which our variable is depending on more than one variable are known as partial differential equations. For example, in this example, u is depending upon x and y. So, here are two variables x and y over which u is depending upon. So, this kind of equations are known as partial differential equation. Now, order and degree, these two are very important terms in understanding a differential equation. Here, order of the differential equation is the highest order derivative present. Okay. For example, let us take another example here, dy by dx plus 8y is equals to 0. In this equation, the variable y is differentiated only once. So, the order of this equation will be 1. Let us take another example, d square y by dx square plus dy by dx cube plus 8y is equals to 0. Now, in this second example, there is a second order of derivative, means y is differentiated twice, and also there is another term that, of first order derivative which power is 3. So, the overall order of this differential equation will be the highest order derivative present, means order will be second or 2. Now, I hope you understand the order. The second most important thing is degree, that it states that degree is the power of the highest derivative present. Let us see the second example only, in which d square y by dx square, its power is 1, whereas dy by dx its power is 3. Although the power of dy by dx is more, which is 3, but still its overall degree of the equation will be 1, because degree is the power of the highest derivative present, and in this example the highest derivative present is of the second order. So, the power of the second order will be the degree of the whole differential equation. Hence, the degree of the given differential equation will be 1. Moving on to the next, which is classification of differential equation. There are several other classifications, but we are only covering linear versus non-linear differential equation. Means, in linear differential equation, dependent variable and derivatives appear to first power only. For example, in this example, dy by dx its power is 1 plus y its power is also 1. So, the equations which have variable or derivatives power equal to 1 are known as linear differential equations. Let us take another example, in which dy by dx whole square plus y is equals to 9, and another example dy by dx plus y square is equals to 9. Now, in both these examples, dy by dx its power is 2, and in the third example dy by dx plus y square equals to 9. So, in this the power of variable or the derivative, either both or any individual, can be more than 1. So, whenever the power of derivative or variable is more than 1, then this all comes under the category of non-linear differential equations. After understanding what is differential equation, its degree, its order and its type, linear or non-linear, now let us switch our focus on its application in physics, because we are studying it under the subject of mathematical physics. So, it is very important for us to understand the application of this mathematical equation into physics. Now, first application is Newton's second law. we are very much aware about this Newton's second law, which is F is equals to ma, that is force is equals to mass into acceleration. And also if we write A is what? Acceleration, and acceleration is the rate of change of velocity, means acceleration is the derivative of velocity with respect to time, hence it is a differential equation. And also we know that velocity is rate of change of position with respect to time. So we can write m dot d square by dt square. Hence the force is equals to mass into second order derivative of position with respect to time. It is an differential equation. Second application, simple harmonic motion. The standard equation or the general equation for simple harmonic motion is d square x by dt square plus omega square x equals to 0, where x is the position which is changing with time and omega is the frequency. It is very much clear from the equation that it is a differential equation. It is a simplest form of differential equation, but it can become more complex when this equation is being damped or the force damped. These are the conditions of mechanical vibrations. So this application of differential equation is very much important in understanding the vibrations. Third application is the radioactive decay. Radioactive decay is related to the decay of neutrons in the radioactive phenomenon. This law is governed by dN by dt is equals to minus lambda n, where the rate of decay of the population of neutrons is directly proportional to the available population of neutrons. Now another application, that is heat conduction. The general equation of this heat conduction is dq by dt is equals to minus k d square tau by dx square, which represents the rate of change of heat transfer is directly proportional to the second order derivative of temperature change with respect to the position. Apart from this, there are some other examples like Newton's law of cooling, which also states that the rate of change of temperature is directly proportional to the change in temperature difference. So there are several examples and several laws. Overall, understanding the differential equation is related to understanding the nature or the laws of physics. So in this lecture we have covered what is an equation, the derivative, and by combining the equation and derivative we have understood the differential equation, the order and degree of differential equation, classification, that is linear versus non-linear differential equation, and applications in physics. In the upcoming lecture we will cover how to solve this differential equation and how to analyze those solutions, because on the basis of solutions only we can better understand the phenomenon of physics